On September 7, 1945, a parade of Allied forces took place in Berlin. A column of Soviet armor moving through the city streets caught the observers' particular attention. 52 heavy tanks, sporting an unusual hull geometry, rolled past the stands where American and British generals were seated. The appearance of these IS-3 tanks, with their distinctive nose shape, stirred a noticeable reaction among the crowd, even though these machines hadn't seen a single day of combat. Western military experts scrambled to document the design details, figuring out armor angles and estimating weapon specs. The look of this new hardware suggested it was superior to anything the Allies currently had. The story of this machine began a year earlier in a design bureau, where engineers were analyzing damage to Soviet armor. After the fighting at the Kursk salient ended, special commissions examined IS-2 tanks, and the data showed that existing models were vulnerable. It was recorded that German 88mm guns could punch through the frontal armor of heavy tanks, leading to significant losses in both machines and crews. Designers realized that simply increasing armor thickness wouldn't solve the problem. They needed a different approach, one that would force shells to ricochet off the hull. In late summer of 1944, work began on a project called Kilovets 1. The main goal was to develop a hull and turret shape that provided maximum ballistic protection while keeping the weight down. Engineers came up with a technical solution that changed the geometry of the nose. Instead of a flat shape, they used a three-slope design with steep armor angles. Nothing like this had ever been used in tank building before, but the need to modernize the fleet demanded new engineering solutions. The 4.3-inch frontal plates were arranged to form an elongated, forward-facing wedge, earning it the unofficial nickname pike nose due to its distinctive profile. While work proceeded on the hull, a new turret was also being developed. Abandoning the configurations of previous models, designers created a flattened, hemispherical turret. This shape offered better resistance to shells and made the tank a harder target for the enemy to hit. The design process was driven by an analysis of actual combat experience, with every technical decision tested for effectiveness. With the war still raging, the demand for modern equipment remained high. By the spring of 1945, the first experimental batch rolled off the assembly line, and the finished units were presented to military specialists for evaluation. Observers were presented with a combat vehicle that looked remarkably different from the standard designs of the time. The design featured a low, streamlined silhouette, that specific wedge-shaped nose, and a flattened turret armed with a 122mm D25T gun. The combination of these elements was meant to ensure high protection and firepower. The tank had a combat weight of 51 tons, could reach speeds of up to 25 miles per hour, and carried 28 rounds of separate loading ammunition designed to destroy heavy armor. Because production started during the final stages of the fighting in Europe, the IS-3 didn't make it to the battlefields of World War II. Despite its lack of combat experience by May 1945, military leadership decided to publicly demonstrate the new hardware. The stage for revealing these newest heavy tanks was the Allied Victory Parade in Berlin. The movement of a column of 52 tanks through the streets of Berlin attracted significant attention from representatives of the Allied armies. American and British specialists, drawing on their experience with machines like the Sherman and the Churchill, noted substantial differences in the approach to tank building. Western military observers recorded the unusual shape and low profile of the presented hardware. Subsequently, Specialized services in the United States and the United Kingdom initiated an effort to gather and analyze the tactical and technical characteristics of this new Soviet machine, as available information was limited and the implemented engineering solutions were evaluated as cutting edge for that period. A key feature of the design was the configuration of the front hull, which was given the name pike nose. The calculated angles of the armor plates were designed to increase the probability of ricochets and provide resistance against anti-tank fire, including German 88mm guns. This solution significantly increased the effective resistance of the frontal protection. The cast turret had a flattened, semi-spherical shape with variable thickness armor, which helped deflect hits from various angles. The successful geometry of the turret later found application in the designs of other heavy tanks, such as the IS-7 and T-10. The D-25T gun, mounted in the turret, had vertical elevation angles ranging from -3 to +20 degrees. The vehicle's crew consisted of 4 men. The driver's station was modernized. Unlike the IS-1 and IS-2 models, a dedicated hatch appeared in the hull roof. This allowed for the elimination of the observation slit in the frontal armor, replacing it with periscopic observation instruments, which strengthened the protection of the frontal projection without compromising visibility. The crew, consisting of the commander, gunner, and loader, was stationed in the turret, which was equipped with a TSH-17 articulated telescopic sight with 4-power magnification and a 15-degree field of view. The primary armament was the 122mm rifled D-25T gun, model 1943, with a barrel length of 48 calibers. The armor-piercing shell had a muzzle velocity of 2,600 feet per second and could penetrate 6.3 inches of armor at a distance of 1,100 yards, ensuring the destruction of most types of armored vehicles of that period. The gun was equipped with a double baffle muzzle brake to reduce recoil and a horizontal wedge breech with a mechanical semi-automatic system. The technical rate of fire was 2 to 3 rounds per minute. The ammunition load consisted of 28 rounds of separate loading. Due to the size of the high explosive shells, 11 slots in the ammo rack were calculated exclusively to hold armor-piercing ammunition. A typical loadout included 18 high-explosive and 10 armor-piercing shells, which allowed the vehicle to be used for various tactical tasks. The coaxial 7.62mm DTM machine gun had a supply of 2,000 rounds of various types, including armor-piercing, incendiary, and tracer bullets. On the turret roof, on a ring mount, a 50-caliber DSHK heavy anti-aircraft machine gun was installed. The mount provided 360-degree fire with vertical angles from -4 to +84 degrees and was equipped with a K8T collimator sight, intended for firing at aerial targets, moving at speeds up to 250 miles per hour at an altitude of up to 1,300 feet. Operating the anti-aircraft machine gun required the gunner to exit the protected space of the turret through the hatch. In the travel position, the machine gun was removed from the mount and secured on the right side of the turret. The tank was powered by a Model V11 liquid-cooled 4-stroke V12 diesel engine producing 520 horsepower. With the tank weighing 51 tons, this unit provided a top highway speed of about 25 miles per hour and a range of 210 miles. The fuel system included 4 internal tanks with a total capacity of 112 gallons, located in the engine compartment and the sponsons, as well as 4 external cylindrical tanks on the engine deck holding 24 gallons each. This volume of fuel allowed for long marches without the need to refuel. The cooling system consisted of 2 plate and tube radiators installed in a semicircle above the main clutch. Fans mounted on its shaft provided heat dissipation when the engine was under load. To ensure the engine would start in freezing air temperatures, the tank was equipped with a heating system. This technical solution was implemented to ensure the vehicle's operability in various climate zones and weather conditions. A classic layout was used, placing the engine and transmission in the rear and the fighting compartment in the middle, which ensured proper weight distribution. However, operation revealed significant technical flaws that hadn't been noticed by outside observers during the initial public demonstrations. In early 1946, a special commission recorded systemic defects. Engines failed regularly, the transmission was unstable, and cracks appeared in the armor of the engine compartment. The cause of these problems was the tight design schedule during the war. The need to produce equipment quickly didn't allow for deep refinement of the components. Some solutions were borrowed from the IS-2 model, while new components hadn't undergone a full testing cycle. The produced tanks were sent for modernization under a program designed to eliminate design flaws. Despite the engineers' efforts, they couldn't fully reach the required reliability standards. By the middle of 1946, production was halted as impractical, with a total production run of over 2,000 machines. Nevertheless, the tanks continued to arrive at heavy tank and self-propelled regiments, where they were operated alongside previous models. With proper maintenance, it was possible to keep them in working condition. The key advantage remained the high level of protection, which was effective against most anti-tank weapons of that period. The only combat application within the Soviet armed forces took place in 1956 in Hungary. Units equipped with these machines participated in operations in Budapest. Only isolated losses were noted, confirming the effectiveness of the armor and weaponry in urban combat conditions against grenade launchers and light artillery. This case remained the only episode of the model participating in combat actions under the Soviet flag. Later in the 1980s, the tanks remained in the Army's inventory. Specifically, a reserve tank division in the Trans-Baikal Military District possessed a fleet of 270 units of the modernized IS-3M version, where some of the shortcomings had been eliminated. The equipment was kept in storage as a reserve in case of a large-scale conflict to potentially reinforce frontline units with heavy armor. When it came to supplying hardware to Warsaw Pact allies, the export of Soviet heavy tanks was actually quite limited. In 1946, Poland received just 2 machines to study the design and train instructors. Those specific tanks were used for parades and training purposes right up until the 1970s. In 1950, a single tank was sent to Czechoslovakia, where it was also used to demonstrate the capabilities of Soviet tank building and to take part in ceremonial events. The main operator of the IS-3 abroad, however, turned out to be Egypt, which purchased a total of about 100 units, including both the base model and the modernized IS-3M version. The first batch arrived in the late 1950s, with the main deliveries taking place between 1962 and 1967. The Egyptian military leadership planned to use these Soviet heavy tanks as their main striking force in a conflict with Israel, placing their bets on the tanks' thick armor and powerful guns. However, during the Six-Day War of 1967, when the IS-3 first saw combat against Western-made tanks, the results were unsatisfactory for the Egyptian side. This was due to both insufficient crew training. Many soldiers hadn't had time to fully master the equipment, and the nature of the fighting itself. The conflict demanded high maneuverability, mobility, and the rapid rate of fire, characteristics where these machines fell short of the requirements of modern warfare. Centurion tanks had the edge over the IS-3 in mobility, and their crews demonstrated a higher level of tactical training. The enemy's rate of fire allowed them to get off several shots in the time it took the Soviet tank to reload just once. Any advantage in frontal armor was often nullified by attacks from the flanks and rear where protection was weaker, and Egyptian crews couldn't always turn their machines fast enough to face the threat. Although there were recorded instances of enemy equipment being destroyed by IS-3 fire, on the whole, Egyptian armored forces suffered significant losses. During the army's retreat, a large amount of hardware, including these heavy tanks, was left behind on the battlefield. Crews frequently abandoned fully functional vehicles, and as a result, more than half of the 72 lost IS-3s fell into Israeli hands in working condition. These trophy tanks were studied, tested, and adopted into the Israel Defense Forces, where they remained in service until the early 1970s. During technical inspections, it was discovered that the V11 engines on many of the machines were heavily worn. Engineers decided to replace the stock motors with V54 diesels, taken from previously captured T54s and T55s that were available. These power plants proved to be more reliable and easier to maintain. Quite often, the roof of the engine transmission compartment was transferred along with the engine. The IS-3s saw limited use as combat units, as the concept of the heavy tank was losing relevance, and the low mobility of these machines simply didn't fit the tactical tasks of the time. A number of IS-3 tanks served as towing vehicles, since their engine and chassis specs were up to the task. But during the War of Attrition in 1969 and 1970, the Israeli army found a different use for these captured machines. They stripped the engines and transmissions from some of the tanks, opening up more interior space to store extra ammunition. These stationary hulls were dug in at critical sections of the front to serve as permanent pillboxes, using their heavy armor and guns for defense. Effectively, the IS-3s acted as fortified positions, firing on Egyptian forces across the Suez Canal. The crews would shell targets on the opposite bank until they completely ran out of ammo. Once their ammunition was gone, 2 of these immobile tanks were recaptured by Egyptian troops who had crossed the canal to attack Israeli positions. The Egyptian soldiers discovered the hulls of tanks that had once belonged to them, machines that had managed to change hands twice. Large shipments of IS-3s were also sent to the Democratic People's Republic of Korea, with deliveries of Soviet equipment beginning in the 1960s. The Korean People's Army had at least 2 regiments equipped with these vehicles. Military leadership viewed the IS-3 as a deterrent in the standoff against South Korea and the United States contingent stationed on the peninsula. The tanks were kept combat-ready, crews were trained, and the machines periodically appeared in parades in Pyongyang. North Korean IS-3s never saw actual combat, since the armistice held after the Korean War ended in 1953, and there were no large-scale tank clashes. Still, South Korean and American commanders had to factor North Korea's heavy tanks into their defense plans for the demilitarized zone. By the early 1970s, the very concept of the heavy tank had become obsolete. A new generation of main battle tanks combined firepower with armor and mobility, making specialized heavy vehicles irrelevant. The IS-3s were gradually phased out of frontline units and replaced by modern designs, though they weren't completely written off. In the USSR, a significant number of these tanks were put into long-term storage in reserve units, kept ready for potential use in the event of a large-scale conflict. By the time the Yom Kippur War broke out in 1973, the Egyptian army had a unit equipped with IS-3 tanks. However, there is no confirmed evidence that these machines ever directly engaged Israeli forces in combat. The military command likely preferred to use the more modern T-55s and T-62s, leaving the outdated models in reserve. By that time, the IS-3 was already significantly behind current armor in terms of performance, making its use against new generation tanks ineffective and highly risky. The story of this machine highlights a major gap between the design concept and its actual service life. A tank developed with cutting-edge engineering for its time, featuring a groundbreaking design, was never used in the conflict for which it was originally designed. Technical flaws kept it from becoming a reliable, mass-produced combat unit, and by the time it might have seen combat, its design was already obsolete. Despite its limited combat use, the IS-3 had a significant impact on global tank design. Its appearance at the Berlin Victory Parade in 1945 caused quite a stir among Western experts, spurring the development of new armored vehicles in the United States and Britain. Foreign designers studied Soviet technical solutions in detail, trying to build machines capable of competing with this model. In particular, the frontal armor layout, known as the pike nose, became a subject of analysis and influenced future tank designs in various countries. The IS-3's distinctive flattened turret shape served as a benchmark for a number of designs developed in the 1950s and 60s. The experience gained from creating this machine was later used in designing the next heavy tank models, such as the IS-7 and the T-10. The principle of differentiated armor with rational slope angles became an industry standard for a long time. Even the technical problems found during the IS-3 service were taken into account by engineers. This led to more thorough development of future projects, helping to avoid mistakes made under the tight deadlines of wartime. A paradoxical situation emerged. A tank that saw almost no combat became one of the most significant models in the history of armored warfare. Its visual look and technical solutions defined the direction of the industry for decades. The IS-3 was perceived as a symbol of the industrial capabilities and engineering school of that era. When these machines rolled through the streets of Berlin, the international community viewed it as a demonstration of the state's high military technical potential. Today, surviving examples of the IS-3 are on display in many military history museums around the world, standing as clear examples of mid-20th century engineering and holding their place among the iconic machines of the past.